All idea of taking the thing almost 400 miles over land had been dropped early on. So Smit International Transport was invited to find an alternative route. And since the thing in question weighed 1,300 tons, measured 16 meters across its middle, and like all nuclear reactors had a very sensitive nature, the outcome was a unique experience in what at any time is a moving business. The starting point was Barrow-in-Furness in northwest England, home of Vickers Shipbuilding and Engineering Limited. The destination, Dounreay Naval Reactor Test Establishment on Scotland's northernmost coast. Along that bleak and rocky coastline lies Sandside Bay, a small inlet 1 mile from the test facility. A soggy up and down mile that our delicate cargo would eventually have to travel. So preparations had to be made for a 30-meter wide track with rock anchors to serve as holes for heavy tackles. That road ended with a 70-degree turn into the test hall. So a pit was needed to enable the cargo to be maneuvered into the right line and height for the last leg of its journey. The 100-meter square concrete floor was finished to a fine standard of smoothness and water tightness. From the 5-meter high retaining wall, a concrete apron led into the final location. The transport operation itself comprised of 5 stages, the first of which called for loading the reactor and a variety of associated ancillary equipment onto 2 small barges. The reactor, or pressurized water reactor PWR-2 to give it its full name, was undergoing final preparations and being cocooned to protect it from the elements. To satisfy the strict demands of the client with regard to flexing, the barge due to carry the reactor had to be stiffened. While all that was going on, the other small barge was being loaded with the ancillary equipment. Long before this, however, a whole range of people, all experts in their own field, had been involved. Following the 4 years it took to finalize the plans, draw up the contract and settle the insurance aspects, there came a 15-month period devoted to overall technical preparation covering every conceivable detail. At this point, one might wonder why they didn't build the reactor in Dounreay in the first place. However, Dounreay has no building yard, and there was the matter of transferring over 200 highly qualified personnel. And so, the reactor, developed by Rolls-Royce and Associates, was to be built by Vickers in Barrow. These high supports are designed to allow clearance for platform trailers to go underneath during unloading. While one barge is being crane-loaded with the bits and pieces, over by the other one, things are being got ready for the shore-to-barge transfer of our primary unit, the strictly passive reactor. The move is accomplished with a system of skidways, jacks, and push-pull cylinders. In the skidways, a succession of PKFV sliding pads see to it that friction is kept at a minimum. Hydraulic jacks above the so-called skid beams ensure that an even load distribution is maintained, while the more human touch takes care that the pads remain in position and get a necessary spot of oil. When both the primary and secondary units are properly loaded and secured on their respective barges, they're towed out to be placed aboard the 24,000-ton deadweight semi-submersible barge, the Giant II, which is waiting in open water out in the bay. First, the barge with the ancillary equipment is moved out of the Barrow dock system. Later, the barge with the PWR-2 will be taken from her specially prepared berth at spring tide. The secondary units, the primary unit. First to be positioned over the submerged deck is the barge with the secondary units. It will eventually be moored against those guide stanchions pointing out of the water. The loading procedure goes like this. Giant II is submerged by flooding her ballast tanks with sea water. The barges are positioned over it in the proper order. And then Giant II is deballasted, lifting barges and cargo out of the water. The same situation translated into reality. Mooring the barge with the secondary units. Awaiting the primary unit, the barge with the PWR-2. Only now at spring tide can it be towed out to Giant II, with ahead of it a 400-mile journey. No medieval monster ever looked like this. The positioning of the primary unit. With both barges in position, the task of emptying the ballast tanks begins. A task that will take all of 20 hours before Giant II is ready to embark on the second of the 5 transport techniques used, the tow to Scotland. Up at Sandside Bay, preparations have been made to beach another barge, the brand new Smit Barge 1, at right angles to the coast at the start of the 1-mile track. Her job? To act as a jetty for the Giant II. A landing strip had been dug out and covered with sandbags to protect the barge bottom when it came to rest here. 30,000 sandbags, each one filled and placed by hand. And the same scene at high tide. The coast of Sandside Bay at low tide and at high tide. The yellow line shows the 1-mile track, with, at the top end, the turning pit and test buildings, at the coastal end, Smit Barge 1 and Giant II. Maneuvering the Smit Barge 1 onto her position on the sandbags. To stop any chance of shift, whatever the tidal conditions, the ballast tanks of the vessel had been completely filled with water. The 400 miles to Dounreay was completed within 3 days. On the morning of the 4th day after its departure from Barrow, the 2-vessel convoy made up of the tug Smit Lloyd 114 and the Giant II appeared on the horizon off Dounreay. Meanwhile, the gap between coast and Smit Barge 1 had been filled in and the sandy road extended over her deck. So as to take full advantage of the tide, Giant II was maneuvered into the bay at dawn and duly moored lengthwise with her stern against the end of Smit Barge 1. And this is where the story will continue on land. The submersible's ballast tanks were flooded with water to prevent shift. Here too, the gap between the two barges is filled in to give a smooth and even ride. And so to transport technique number 3, rolling PWR2 over 90 inflatable rubber airbags, each one 9 meters long, 60 centimeters in diameter, and carrying a total weight of 2,400 tons. Up and down a hill with a maximum incline of 5.5%, covering a distance of 1 mile. Making use of two 40-ton traction winches installed on deck and tackles secured to the rock anchors at either side of the track, the barge carrying PWR2 rolls slowly but surely towards its destination. There was nothing new about this technique, but until this point in time, the record was a weight of 1,000 tons over a distance of 100 meters. Now the figures read 2,400 tons and a little over 1.5 kilometers. Once the primary unit had been brought ashore and parked, there was sufficient room to take off the second barge, which was light enough to be pulled by bulldozers. Steering loads of this order can be quite tricky, but with experience, a degree of careful calculation, and a few lusty commands of the good old right hand down a bit variety, it was possible to keep things on a steady course. As soon as the airbags came free at the rear, they were taken to the front again by local tractor drivers, while some of the more technical staff made sure that the bags still rolling were kept at the right air pressure. Rumour has it, by the way, that airbag racing will replace tossing the caber at the next Highland Games. The journey from the bay to test establishment took 6 days at an average speed of over 30 meters an hour. However, airbags could not have coped with the final turn into the building. And so the fourth transport technique was introduced, the so-called water skating, carried out in the turning pit at the end of the sand track. The turning principle is simple. The unit enters the pit and is put on the water skates to reduce friction, so that winches and tackles can turn it into line for final transshipment into the hull. From this reservoir, pumps supply the water to the 28 skates, which are in position under the barge. By means of heavy tackles connected to winches at the edge of the pit, the load is maneuvered towards the desired position against the retaining wall. Water skates are basically large pallets made from plywood, in this case measuring 2.5 meters by 1.2 meters and 20 centimeters deep, and having a rubber strip around the bottom edge. Water was pumped into the skates at high pressure to lift the load off the ground. Much the same principle as the hovercraft, only using water instead of air to give lifting capacity. In this case, about 90 tons per skate. The pumps are switched off only when the moving is completed and the load is where it has to be. For the last stage of the reactor's transportation, it was back to the skidways, jacks and push-pull cylinders to move it into the hull, from which the lower end wall panel had been removed. Precision now was everything to place it within the tolerance demanded. In the event, it was pretty good for a first effort, a neglectable 1 millimeter out in one direction, 0.5 millimeter in the other. Now for the unloading of the ancillary equipment. The smaller barge had by now been rolled on airbags and towed by bulldozers to a spot near the hull. For the unloading, multi-wheel bogies were employed, the fifth transport method. By cutting through a small artificial hill close by, a sort of bridgehead had been created so that via roll-on, roll-off ramps, it was possible to drive the bogies underneath the two heaviest items on the barge and take them straight into the hull. As for the smaller items, these were unloaded by crane. This done, there was time at last to pause and reflect that Smit had been responsible for every aspect of this whole complex operation: project management, engineering, door-to-door delivery. All the world loves a tidy workman. And one of the undertakings Smit International Transport had given at the very beginning was to restore the area to its original state once the job was done. This is Sandside 4 months after man and machine had departed, leaving little trace of landing strip, haulage road or turning pit. Indeed, the same attention to detail that had put the PWR-2 to within a millimeter of perfection had also gone into rebuilding 1DSW, or to give it its full name, the Dry Stone Wall.